Easily the best way to level up your game as a security researcher and get better at uncovering those niche vulnerabilities and even just improve your approach to auditing new code bases in general. Easily the best way to do all of those things is by learning from other security researchers and understanding how they go about doing an audit. But unfortunately, of course, sometimes it can be hard to get that opportunity to peer over the shoulder of another security researcher and get to understand exactly what they're thinking and how they're approaching a new code base. So of course, that's why I've decided to make this series where I basically live audit together with Dennis, a research engineer from Protocol Labs, an implementation of Protocol Labs hierarchical consensus model. And essentially in this series, you get to see exactly what I'm thinking as we go through these contracts, and you have all of the context that I do as we're going through and finding vulnerabilities live. So today in this episode, we're continuing our audit of the communication layer between these subnets, and we actually find some pretty tricky problems that are associated with this design and specifically the implementation of the design. And we're getting pretty close to fully understanding the code base and having a full grasp on the code base from this review. First, real quick, before we dive in, of course, my name is Owen, and over a year and a half ago, I founded Guardian Audits, and ever since then, we've uncovered probably easily over 100 different critical and high vulnerabilities across dozens of smart contract audits of hundreds of different smart contracts. And I've easily spent over 1,000, probably even 2,000 hours at this point auditing smart contracts. And my goal with all of these videos that I put out, and especially this series, is to distill down everything that I've learned from all of that experience and give it to you so that you can ultimately become a much, much better smart contract developer, security researcher, whatever you're looking to be in a fraction of the time. All right, so without further ado, let's get into today's episode.
So we got subnet ID. So we're looking at commit top-down message function, where we commit top-down messages for their execution in the subnet. Network name. Network name is the gateway actor network. We get subnet ID.
Yeah, exactly. This makes sense with what we decided, right? Because the network name is the thing that's higher up, and then we're going top down, so the message.2 is lower.
So the destination is subnet ID, and we calculate the name of the concrete name of subnet ID by network name of the gateway, and that will be subnet ID.
Yeah, exactly. That's the very next step in the path to get to the cross message.2.
Yeah,
makes sense.
And subnet gets subnet ID. We get a subnet, check whether it registered or not. We also got the storage for that subnet, and we increase. So we can use the same, right?
Yeah, exactly.
We increase calculation supply because we fund the network, and because of that, we increase circulation supply. We fund the child subnet, and then we push the cross message in the top-down messages of this subnet.
Got it. So then these top-down messages will have a commit top-down checkpoint, which will actually go and execute these on the subnet.
Yeah, then subnet, then IPC agent will get the state and propagate it to the child subnet.
Okay, got it. Yeah, so the IPC agent basically does that.
No. Sorry. No. That's correct. So we call commit top down, then distribute rewards. Yeah, commit top down and then distribute rewards.
Got it. So one thing that's interesting actually is I remember 2 days ago when we were going over the commit bottom up, the circulating supply was only changed when we actually did the commitment and we made the commitment in the gateway, right? Maybe this is fine, but it's interesting. If we think about it, at the end of the commitment window, only when we hit the end of the window, that's when the circulating supply was changed and subtracted from specifically. But now when we're changing the circulating supply for this commit top down,
I believe that that was the same function, because we have only 2 times where we touch circulation supply.
Yeah, exactly. So I'm thinking about like the timeline of when these are happening, right? So in the one we were just looking at, the really big function, right? In that one, that function only gets called at the end of a window, right? So after all of these have been voted on and stuff like that, and we commit up to the parent, then we decrease the circulating supply, right?
Yep. We
Only
decrease, we release.
at the end of the window, right? When we commit. But the thing about when we're increasing the circulating supply here in this smaller function, when we commit top down, this can happen at any time, like in the middle of a window, like intra window, right? So like this doesn't have to be like all of these commitments for these top down messages, they're aggregated within a window. And then at the end of the window, then those are applied top down. And so the circulating supply is incremented throughout the window, not necessarily at the end of a window. And there may or may not be an issue with that. It's an interesting like juxtaposition.
So you mean that if I call fund, then I increase the circulation supply immediately.
Mm-hmm. Yeah, exactly. Whereas if we
in the second case,
yeah.
So in both cases we increase it using commit top down, but in the fun case I call commit top down message immediately, and if I call send cross and propagate, actually that was, so we don't call so we decrease circulation supply when we call submit commit child check, right? Yeah, commit child check, and that's we do using clock, and commit top down messages, and commit cross message again, send cross. But send cross is also called whenever I want, and propagate, and probably propagate is also called when it's necessary to propagate message from top to down.
Right. So I can increase the circulating supply of a subnet immediately.
Yeah.
But when it comes to decreasing the circulating supply of a subnet, that has to happen at the end of a window, right? When we commit a checkpoint.
Yeah.
I think that would be fine. Certainly if it was the other way around where we were decreasing it first and we had to wait to increase it, then there would be like underflow issues. But yeah, it's something to note. I can't see any initial glaring issues with it. It's just interesting. Like, yeah.
Yeah, but I would definitely write it down.
Yeah. So where were we? We were looking at fund, I think, right?
Yes, we are still here. Yeah, and we push cross message. Cross message, and that's it. And then distribute rewards.
Yeah, and we went over that, I think, in the beginning. That goes back to the subnet actor. Yeah. Okay, that makes sense.
Yeah, we looked at it.
Yeah, I think that's interesting because I don't. Yeah, the checkpoint fee.
Where do you see checkpoint fee?
Yeah, I was just thinking about earlier what we were talking about. I don't think the checkpoint fee is ever like actually dispersed, but I think that's what he said is like unimplemented at the moment.
Yeah.
Yeah, okay. Because I would expect like in the commitment to, I don't know what that would look like, but yeah, anyways. So I think that's fund and release. What about like the cross message function? I think we looked at it a little bit, like send cross. Yeah, we looked at this a little bit, and there's already like the fee stuff, but yeah, maybe some other stuff.
Yeah, so we have started looking at that function 1 hour ago, right?
Yeah.
Okay, and yeah, we stopped here.
Okay, so yeah, we just had some validation, and then it's actually interesting. We're like constructing the message for you, even though you already sent it, right? We're just overwriting that stuff. There might be a trade-off there where So I see that the cross message has to be, that's like a memory parameter. Now I don't know how cross message is used in that internal function later on, but there might actually be like a pretty decent gas savings in optimization if instead of like writing that cross message, like writing the destination, the network name and message sender, instead of coding that, like assigning that onto the cross message, we could just have like a custom revert that checks all of those. Like the destination is the parameter, the network name is this network name, the raw address is the message sender. Verify that rather than write it to the cross message. And then we can make the cross message call data, and that will save probably a decent amount of gas, but it depends on how it's used in the internal function. I assume it could also be call data there. So yeah, that's something to look into. Okay, great.
So this is external function. We don't use it, fortunately, internally.
Mm-hmm.
So from my perspective, it's a good idea. So in that case, we don't even need the second parameter because it will be in the cross.
Yeah, absolutely.
Okay. So then we commit cross message. Commit cross message. We haven't looked at this function. Okay. Commit the cross message to storage. Signaling if the commit message was bottom up. Some fronts need to be burned. So this is critical function. Okay, so we get the destination and we check. So if route length is 0, that means that
That's like nonsense. There's
so the kind of empty address.
mm-hmm.
So we need at least one address in the route section.
Yep.
Equals network name. Okay, and invalid cross message destination. So probably that means that it was routed to this function, but there was an error in routing.
Yeah, so in the context of calling this from that external function from send cross, it would be like I'm trying to send a cross message to the same network, which doesn't make any sense. So yeah, I think that's a good validation to have.
Do we need other validations?
Yeah, that's interesting. I mean, you would want to validate, of course, that it is a valid network name, right? That I'm not trying to send something to just some arbitrary subnet to. Like if we went back to the function we're looking at, I'm pretty sure, so you provide a destination. That will be a part of the change that you suggested, actually.
Yeah, destination in a cross message.
Yeah, in the function we were just looking at in send cross, in this one. Yeah, like exactly like you're saying, instead of having a destination as the first parameter for this function, we would instead want to just have validation on the cross message .to, and a part of that validation should be that it's a valid destination network, right? Like it's actually registered as a subnet.
Yeah, send cross destination equals network name. Yeah, so do you mean that?
Yeah, it's tough actually, because like I wonder if this is even possible, because if I'm sending a cross message, I should be able to send a cross message to something that this gateway actor doesn't even know about, right? Like a subnet that is completely on the other side of the tree of the hierarchy, right?
Yeah, but the subnet in the middle should be registered, must be registered.
Oh, like so I guess that's a question that I have then. Is this destination the very next subnet, or is it the ultimate destination of the cross message?
Ultimate.
Yeah, like I would assume it's the ultimate.
So root B C. So my understanding is that here we can get this message, and we can get the destination as /R/B/C, and here we know that there is a subnet B, or even so let's say destination is /b/c/d. We know that the destination /b is our network name. We know about subnet /b/c, right? Because it must be registered in our gateway actor. We don't know directly the subnet /r/b/c/d, and we can check that, but we can check. So we check this information right now, and we don't check this.
Yeah, right. So there's no way to completely validate.
Yeah.
Yeah.
But we can validate the channel subnet.
I imagine you guys already have logic that does something like that, though, because you have to, some way or another, determine whether or not I'm going to go up or I'm going to go down, and to which subnet am I going to go down. So I imagine there's already something that does that in the function we were looking at. Yeah, in commit cross message.
But we don't check it here.
Yeah, but I think if we go to
you mean that we probably have this logic, but we don't use it here in this function.
Yeah, I think it's probably used deeper down. Like there must be some way. You got to know if you're going up or you're going down, right?
Yeah. Yep. Here.
Yeah. Oh, so it's just a type. Is that on the message? Let's see. Apply type. So that when we apply type, that must tell us whether or not we're going up or down.
So apply type. What is apply type? Message apply type. Network name should commit bottom to common parent from equals
common parent.
So if is the common parent of the destination equals so that says probably if we receive this message from the gateway, from our gateway actor, then we should not commit bottom up.
Right. So I have
so if we receive this message from the parent, we should not commit bottom up because that's not bottom up.
Yes. Right. So, and that's almost like if this is being propagated, right? Like if the from, because when in the function we were just looking at that, in the external function, we hard code the from as this network name. So in the way that we're thinking about this currently going through it, the from is the network name, right?
Yes. So we just check the flow. Is it bottom up and top down? But we can trust to this. I hope the logic is that we can trust just the type, just 2 bytes in the message. There can be arbitrary data, and because of that, we check real direction. Is it bottom up or top down?
Yeah, that makes sense.
Should commit. So if we should commit bottom up, we commit bottom up. Otherwise, we check whether cross message value.
That makes sense, right? Because if we're going up, then the funds on that are being released in the parent. We need to burn those funds on this subnet here.
Okay, so if we should commit bottom up, then we burn. We commit bottom up, then burn. If we return that we don't need to distribute reward. Otherwise, IPC top down. Apply type. If it's equal top down, then we increase apply top down nonce by 1.
Yeah, I think this could just be like an if.
Interesting, because here we don't check the real flow.
Well, I think if we look at apply type,
maybe that doesn't make any sense here.
Yeah, so I guess my question is, what's the bottom up case where you should not commit bottom up, because then you end up committing top down?
What is the case when we should not commit bottom up? When the message is bottom up, but we don't commit bottom up, right?
Yeah, exactly.
So the type bottom up.
And I think we have to understand what apply type does on line 587.
Okay, so we have apply type. Apply type if bottom up.
Like, how do we derive what the apply type is? Like, what does the apply type function do? Interesting. Current parent subnet equals the message parent subnet. Okay, so there's several cases here. There's the cases where we're propagating to the next network, and there's the case that we're currently looking at, which is send across. We're creating it on this network.
Yeah, so we check whether the source of the message is the same as our current message.
Yeah, so
Our
I'm
current
gonna think about this from the context of what we're looking at with the external function, where we're creating this cross message literally on this network. So we don't have to worry about we don't actually have to worry of the current parent subnet being different from the message parent subnet, because these are the same. That'll make it easy for me to understand at first. So those things are going to be the same because the current subnet is the same as the from subnet. So that first dot equals is true. Then the thing that we care about is the from subnet, the length of that, so the depth of that in the hierarchy. If the depth of the from is greater than the depth of the message parent subnet is the common parent of from and to. The common parent of from and to, it's higher up. Honestly, I think you could just...
We should be careful with naming here, because current parent subnet is current subnet common parent, and message parent subnet from subnet.
Yes. And that's what's on the message. The way I'm thinking about it right now is from the lens of the current subnet being equal to the from subnet. But basically, so this, if we are saying if the from subnet, we're talking about the length, so the depth from subnet, if it's longer, it's deeper in the hierarchy. And
So
then
let's see, we are here. This is our parent, okay? And message parent subnet is the same. This branch is where message came from, correct? And now from subnet route length greater than message parent.
Yeah, so if the from subnet is
probably we are considering this case. I mean, this is one of the examples that satisfies the code. Bottom up, and otherwise return top down.
Yeah, so that makes sense to me, actually, because like the reason we have to calculate the parent, I just realized, is because we can't just compare the length of the to and the length of the from, because they might be on different branches, right? So we have to get the parent, the common parent between them, and then we have to see, is that parent higher up? If it is, then we need to go to the parent first and then go down to get to the to ultimately. And so I think the case that we were concerned with when we were looking at the interesting thing where we get an apply type of bottom up, and then we actually don't know if we should still commit bottom up, is this case where there's a case where the length, the depth of the from is equal to the root, the parent subnet, but then that would be top down. So that would be like, we're standing on this, we've just come up and we need to go down, or something like that.
I'm not sure that, maybe that's trivial, but I'm not sure that all messages can be classified as a bottom up and top down using this logic.
What counter case do you think there is?
For example, this, I mean, what if the message does not satisfy this if statement? The function returns top down. This is default. So it's apply type function says that almost all messages are top down, but if these conditions are true, then this is bottom up message.
Yeah, I think especially that first part of the if, the first part of the and condition, I was thinking from the lens of we're on the same network, so I was kind of ignoring that. But if I think about that, the current parent subnet equals the message parent subnet. I actually don't think that should be considered when you're worrying about, like, when we're talking about bottom up or top down, I don't care where the message was originally from. I just care about where we are now and where the message has to get to.
Yeah, that's correct, but only if source and destination are also correct. If source and destination are arbitrary names, it's not possible to say. All right. So if, let's say, the source is CB, let's say root, and the destination is root, I don't know, A and B. They are not comparable.
Right. Well, so that's why I think
Direct. If we follow the path, then of course each age and names corresponding to that age are comparable by definition. So if we call this function on validated data, then no problem.
yeah, it's like you have to know the full path. Yeah, I'm actually interested. How are they computing the common parent? I guess you just take both of those and say, okay, the common thing is root. That's the longest common thing.
Probably using that function.
Yeah, there's probably another function in this library called, what is it, common parent or something that does something similar.
Okay, so should we continue?
Yeah, I think there's some interesting points there. I'm still not sure of. There's an interesting thing here where I can tell you that the apply type is bottom up, but then still only sometimes should commit bottom up. And then what's especially scary is that if the apply type is bottom up, but should not commit bottom up, we actually commit top down, which is interesting. And I'm sure there's an edge case for that like a reason for that, but it seems scary at first glance. Okay, great. And then I think we could have sort of skip ahead to where I think the only part we haven't really looked at yet is the applying of these messages, right? So like we talked about how they get sent, how you fund and release, but how do these things get applied in the gateway, right, and actually take effect in the subnet?
Yeah. So commit cross message should burn. That was the next function. Should burn, should distribute rewards and cross message. Transaction side effects from the commitment cross message. It burns funds. If should burn, table burn funds actor send value. So burn funds actor is a trusted contract.
Yeah, like a debt address or something like this.
Send value.
Yeah, I think that makes sense. Right, we're just trying to burn. If we need to send to the parent, then we want to burn those funds on this subnet.
Distribute rewards. Magic happens here. To subnet ID. If to subnet ID route length is 0 or get actor is address 0, return. And recall distribute rewards.
This is interesting because we're talking about a cross message where it looks like we're like assuming that the 2 is always below the current network name. So we're calling this down function. But can't this cross message side effects, doesn't this happen for top down and bottom up? Like it depends on where the message is supposed to go. But here we're always sending these rewards to down.
Why down? Subnet ID is a subnet in the same state.
Yeah, so we have the cross message .2, like the destination of the cross message. Actually, this is quite dangerous actually, because the assumption of the down function, which we're calling on line 625, the assumption of the down function is that the first subnet ID provided to the function, the first parameter, is further down in the hierarchy than the second subnet ID provided as a parameter. So that's an assumption of the down function, but that assumption doesn't hold true for every cross message. And maybe that's what should distribute rewards follows. Maybe that Boolean enforces that should distribute rewards is only true when the cross message is going down.
And by dangerous, do you mean what? Sending rewards to an arbitrary, not the target contract.
Yeah, a few things could happen if we did attempt to distribute rewards and go down when really the message went up, right? So I don't know exactly what will happen when we call that function. All I know is that it's going to do something wrong. Either it will give you a 2 subnet ID, which...
Sorry, 1 second. When you say go down, you mean that, let's say, we are here right now, the gateway actor. In this gateway actor are registered 3 subnets. So this is B, and this is B1, B2, B3. Exactly. And when they say down, we just get, let's say, B1 address.
Yes.
right? But I mean that we don't go down to another gateway.
Yeah. We're using this to calculate
Okay.
the subnet ID of the actor, which should get these rewards, right?
Okay. Yeah.
But okay, so if we look at the function for down like we did, the assumption of that function is that the first parameter is lower in the hierarchy than the second parameter. That's
Yeah.
the assumption of the function.
Yeah.
But as we know, the cross message .2, that could be anywhere in the hierarchy relative to the network name, the current network, right? It could be above the current network. It could be below the current network. So in the case where it is below the current network or above the current network, e.g., we are going up, we're doing a bottom up, then we should not be calling that function. And we might avoid this. It depends on that Boolean value should distribute rewards. If I were to summarize this in one statement, I would say we should never distribute rewards if we're going bottom up. And the code could absolutely already be doing that, depending on what that Boolean value is. But that's something to verify.
Yeah.
All right, great. And then, yeah, that's pretty much, then we just distribute rewards and stuff like that. All right, that is all for this time. We have almost covered everything there is that this code base has to offer. And in the next episode, this will actually be the last episode in the series. We've come a very, very far way from since we initially started the series, and I've hoped that if you've stuck around across all of the episodes thus far, you've picked up a few things, learned a few things, maybe you added some things that you want to tweak to your process and your approach to the code base. And yeah, I hope you've taken the chance and found value in this series to improve your security research approach in general. Of course, if you are a part of a team that is shipping a new cool DeFi protocol and you're starting to think about security reviews, then I want to hear about your protocol. And in fact, I want to hear about it so much that if you go to guardianaudits.com/quote and you submit your protocol information, I'd be more than happy to take a look at your code and do an initial first pass and point out anything that might be a glaring issue or some informational notes that ought to get resolved before going into an audit. And we can discuss these things on a call when we figure out what exactly your options are for an audit. And of course, if you happen to know a team looking for a security review, then of course send them to guardianaudits.com/quote. And if you're interested in connecting with other security researchers, other people who are interested in Web3 security from across the world, and being able to ask questions to over 800 different security researchers and get an answer, and even just contribute your experience to the community, then go ahead and head on over to lab.guardianaudits.com and fill out an application to join our free community of security researchers. All right, that is all for this time. I can't wait to see you in the next one.